We've also looked at UFO materials. You are in possession of UFO materials yourself.
Claimed UFO materials.
Claim alleged UFO materials. That's right. So, what's another term? Weird materials that don't seem to
that have a story.
They have a story that doesn't seem to be of natural origins, but it's not. There's a process to proving that, and that process may take decades, if not centuries, because you have to keep pulling at the string and discover where they could possibly come from. But anyway, you're in possession of some materials of this kind. Can you describe some of them, and maybe also talk to the process of how you investigate them? How do you analyze them?
Right. So let's say that there's two classes of materials that I've been given by people, and they're not given by like the government or anything, just given people who've collected them, and there's a reasonable chain of evidence associated with them that you believe is not just a pebble somebody picked up off a road. There are almost always things that people have claimed have either been dropped off as like some sort of a leftover material, molten metals, or they are from an object that was released from this that kind of exploded. They're almost always metals. I have some couple of things that might be biological that are interesting that I haven't really spent a lot of time on yet. When you look at a metal, you basically, well, okay, what are the elements in it? And what's it made of? And so there's pretty standard approaches to doing that. Most of them involve a technology called mass spectrometry. And there's probably about 5 or 6 different kinds of mass spectrometry that you could bring to bear on answering it. And they either tell you, depending upon the limit of the resolution of the instrument, they either tell you the elements that are there, or they tell you the isotopes that are there. And you're interested not just in knowing whether something is there or not, you're interested in knowing whether there are, the amounts of it. And in the case of elements, how many different isotopes are there? And that's kind of where, in some of these cases, it gets interesting, right? Because in at least one of the materials, as we first studied it, the isotope ratios of, in this case, it was magnesium, are way off normal. And I just don't know why. It doesn't prove anything. It just, all it proves is that it was probably accomplished by some kind of an industrial process. Whether it's the result of a process or whether, and this is sort of the leftover, or whether it was made that way for a particular purpose, I don't know. All I know is that it was engineered. That's it, right? But then the question is sort of, you go one step deeper. Why would you engineer it?
Right. Well, why and what does the engineered means? There's all kinds of. It could be a byproduct. It could be the main result of an engineering process. It would be a small part of the engineering process that is the main part.
Well, so the ratios of isotopes for any given element are basically the result of stellar processes. A supernova blew up sometime several billion years ago. That became a cloud. Those atoms coalesced gravitationally to form another sun and a ring that became a rocky planet. And the ratios of the isotopes were determined at the time of that explosion. And so everything in the local solar system is more or less of that ratio, depending upon certain gravitational difference. But by fragments of a percent, not whole tens of percent difference. So what do humans use isotopes for? Mostly to blow stuff up. I mean, the vast majority of the isotopes that have been made in the per pound or ton are things like certain ratios of plutonium and uranium to blow stuff up. We don't make or engineer isotopes, which it's today is relatively easy to do, but it's still expensive, for any other reason apart from, let's say, as anti-cancer. We use stable isotopes in money these days as a counterfeiting tool. You basically embed certain ratios of isotopes in to make it harder for counterfeiters to accomplish. But other than that, we don't do anything with that. So why would you make grams of such material in this one case and drop it around on a beach in Brazil?
So which case are we talking about?
Describe that Brazil case. This is the Ubatuba case.
Can you describe this case a little bit further? Like what material we're talking about, just the full story of the case.
So
it's an interesting one.
It's an interesting one. So a fisherman saw an object that released something, or it exploded, and it was this I've got some big chunks of it, relatively pure magnesium, with obviously something else in it because magnesium burns. So it had something in it that would, other metals, simple alloy, that would prevent it from basically burning up. And so the question is, and so then we had two pieces that came from two different chains of custody, both claimed to be from the same object. At least physically, when you look at the two things, they look the same, right? So we took small fragments of each of them. We put them in an instrument called a secondary ion mass spec, which is an extremely sensitive instrument, and it can see down to 0.0001 mass units, which is important for, let's say, more arcane reasons, but it's a sensitive instrument. And so one of the chains of custody, we had two pieces from the same chain of custody, and then two pieces from the other chain of custody. One of them had completely normal magnesium isotope ratios, magnesium 24, 25, 26, and the other was off. Not just like slightly off, way off. And they were both off to the same extent. So, it was sort of like you had an internal control of what was normal, and you had this other one which was wrong. And so you're left with kind of an open question. Was this a hoax? Were these two chains of custody, one of them a hoax, that somebody purposefully introduced those things? Because you could do it. It would cost a lot. I mean, at the time that this was found, I guess the 1970s or so, might have been earlier, I forget. The amount that I had would have cost several tens of thousands of dollars to make. And again, it's not something you would just throw around. And why would you do it in the hope that some guy 30 years from then would pick it up and study it?
Yeah, it's a very subtle troll.
It's a long-term plan. So I just don't know. I just don't know what to make of it, except it's interesting. So a different kind of question that you're asking is, what constitutes evidence? Right? So is this sufficient evidence? Absolutely not. But somebody's put it forward. I have the time. It's my time. I'll study it. And my objective is to sort of take those that I think are credible enough and do a reasonable analysis, put it out there, and maybe somebody else will come up with an idea as to what it is. Now, what would be better is some sort of true technology, right? Something that is obviously, we don't have it, and people like Neil deGrasse Tyson and Seth Shostak have come out rightfully and have said, when you show up with, something really obviously technological that we don't understand, then we'll pay attention, right?
Not just material.
A piece of metal is interesting, but several of the things that I've looked at and other things that people have come to me with, we found to be completely banal, or were actually pieces of aircraft that were invented back in the 1940s.
Yeah.
And so take them off the table.
See, but I think, again, I think showing up with technology that humans would find completely novel is actually a really difficult task for aliens, because it obviously can't be so novel that we don't recognize it
For what it is. Yeah.
for what it is. And I would say most of the technology aliens likely have would be something we don't recognize.
Mm-hmm.
It's actually a hard problem how to convince ants.
Mm-hmm.
Like, you first have to understand what ants are tweeting about, like what they care about, in order to like inject into their culture, because that's why I think it would be the technology that you could present is in the space of ideas, is try to influence individual humans and with the encounters,
Right.
and try to, with this kind of thing that you mentioned about us not taking messages about us not taking care of the world. It's difficult for them to understand. You have to come up with trinkets that impress us. I mean, maybe the very technology, the fascination with the development of technology and the development of technology, the actual act of innovation itself is the thing that they're communicating.
Right.
I mean, this is kind of what Jacques Vallée thinks about, is the role of
The control system, he calls it.
the control system.